You want it, you need it, and really it's your precious when it comes down to it. So your sources are going to be apps, databases, streams, buckets, anything that generates data, anything that stores data, that's your source. So I know the general concepts, but we'll go into some example pipelines. We're just building the foundation. So then, so then what's a pipeline? So what's ETL? We talked about ETL, we've talked about streaming, and pipeline is kind of a new concept, but it really makes sense. It's been around for a long time. I'm going to define it as a flow of data which can be forked at any stage of the flow, or almost any stage, and that's by design. And simply put, it's just ETL plus, or ETL plus plus if we're going to increment it, right? And so this all sounds great, but why? Why these concepts? Why serverless and why infrastructure as a service? It's easy to maintain, it's easy to scale, it's easy to build. It's easy to segment, it's redundant. Why streams and streaming? You can get your real-time data, which is ever more present and valuable as you're trying to build recommendation engines and do auto-driving vehicles and all your real-time data. And then you also you can tap into a stream, that may be forming a transformation here and a transformation there on down the line. And maybe the data you want is actually at this part of the transformation process. Or maybe it's at the beginning for a data enrichment process, or maybe it's at the end or anywhere in between. And then why pipelines? Really, it's the best of both worlds. So we built, we'll see that in just a second. So the most important concepts are going to be, GCP, most important concepts are our technologies. So I guess we talked about concepts, and we'll talk about these guys again. So what is BigQuery? It's a serverless data warehouse, which is actually really cool. You can store petabytes of data and then query from it, and you don't have to worry about resource queues. You don't have to worry about anything going down. You can just query it, and you can give everybody, all you have to worry about is who has access to what data if you have like HIPAA compliance or something. But if an executive wants to query all of the data in all the tables, it's not going to hose everybody else, which can happen sometimes. And you give them, the capital account because they pay all the money and cut our budgets, but you don't have to worry about it running everybody else over. Trying to get your work done. Why Google Cloud Storage? Globally distributed, API accessible, redundant, cloud stored objects. We talked about data flow, process streaming and batch, and you do it simultaneously, and you can transform data on the fly. Data proc is our flexible, disposable, scalable Hadoop cluster. PubSub is our message queue again, and then our ML engine allows us to focus on models, on operations. And it ties in easily to Google's vision, language, and text to like wave to text translation models. Just their AI and algorithms that they've, their machine learning models that they've already developed. You can take advantage of that. And then, so why these technologies? Why App Engine? Serverless, auto-scaling. It's stateful, whereas it's easy, and it also has really cool versioning. So if you have a new version, you're putting it into production, you've done all your regression tests, you've got dev, QA, beta, and now it's in production, you don't have to throw in 100% traffic at it right away. And you still have your old version that really, you can literally drop down and say, you know what, deploy the old version again. Something happened, and we can also automatically load balance where you can say, let's put 10% of our new traffic, or all of our production traffic, on this new version, and keep 90% of it on the previous version that we know works, and that we know what the bugs are as well. And so that's your green-blue deploy, if you haven't heard of that before. And then slowly you can start to level, let's do a 20-80, let's do a 50-50, and let's then do 90-10. 90% of your traffic is on the production and 10% is on dev, and then pretty soon you have a successful deploy. Or if you don't, you just roll it back to your previous version and it's done. So why Bigtable? Bigtable is your real-time, essentially in-memory, it is, your object store database. So if you've worked with Cassandra, or Maria, or Mongo, or Couchbase or anything, that's essentially Google's take on for Bigtable. So you got JSONs, document stores, you're going to write your indexes for it and everything, but it's millisecond latency. So if you have something like a recommendation engine that needs to take click analysis and serve something to a website, that's what you're going to use. And then TensorFlow is your open source framework used by ML engine, or it's most friendly with it. So the most important concepts, that's what I want to talk about, is storage and compute. So if you take one thing away from what we're talking about here, is the paradigm to separate storage and compute. So you don't have it on disk, and you're querying it, you have your buckets, and then you have your cloud functions or your app engines, and then you're serving data to everything that's processing it, and then you land it in storage somewhere else. So Google Cloud Storage is your storage. You can store data in BigQuery as well and pull directly from it. VM persistent disk, no thanks. That's not going to be separating storage and compute. That's going to tie them together, which is traditional, and it's very easy to do, and it works. But when you're going serverless, you don't really have a concept of specific disks. Disks are kind of ephemeral, or you're not worried about it. You just drop it into your bucket store, you put it in multi-regions, and you have your redundancy. Compute is going to say you're going to scale up a data prop cluster, you're going to use App Engine, you're going to use Cloud Functions and your ML engine, and have these scale for you automatically as they receive load. So for an example pipeline, this would be a simple serverless ETL. It's your source database, might go to a cloud function, might take a dump file, your daily batch load or something, put it in, land it in the cloud storage. You might have a second cloud function talk to, have a trigger on your cloud storage here and say, oh, hey, there's a new file. It's a CSV. Let's load it into BigQuery, or it's a JSON. Let's load it into BigQuery. And this is an automatic process. It's a very simple ETL. It just goes from here to there. And if you want to tap into it, I guess it could be kind of a pipeline, but it's not really. We'll see what a serverless pipeline might look like is, let's just say all of our data is already in BigQuery. So BigQuery itself is serverless, right? It's just, you're not managing the infrastructure, the data's just there, you just query from it. And then you might have data flow transforming stage 1, stage 2, stage 3, and then it might be putting it even back into BigQuery. Maybe it's a new table, maybe it's enriched data. And that's kind of the process we're looking at here, where you go from source to destination. Here we have source to destination, even if it's the same destination. But when we build upon this, in data flow, we might fork stage 1 out to a PubSub and have BigQuery subscribe to that topic, exactly like the data enrichment I had talked about earlier. And then on stage 2, you might PubSub out to App Engine, and then maybe there's an algorithm to maybe scrape a certain site or images, or let's get these files that we might use later to help generate some labels or something. Then stage 3, in the transformation process, it might be ready for a Dataproc Spark job, right? And then after your Spark job is done, all the file outputs there go to PubSub, which then your ML engine is subscribed to all of your new PubSub material, any new messages that are in there. And then again, ML engine might take its output and send it to cloud storage or BigQuery. And so really, we go from this traditional ETL to pipeline. And so that's what it looked like earlier. And then here, we can use our source database again, or our BigQuery, and the process, the concept remains the same. You're forking it at any stage that you need to, and that's by design. And then Q&A, separate storage and compute. Does anybody have any questions? Okay. So PubSub and Dataflow are here as well. They don't sit in storage and they don't sit in compute. They're just kind of in the middle as they are data messengers, essentially. So and that's why I put them here in between. But storage and compute is going to be your buckets and your BigQuery and your Spanner and Bigtable, data store, Firebase, and then compute. It's going to be like your Dataproc cluster, ML engines, app engines, cloud functions, all these serverless compute pieces, for lack of a better term. And then covering the concepts again, we talked about BigQuery, Google Cloud Storage, PubSub, Dataflow, ML Engine, Dataproc, App Engine, Bigtable, Cloud Functions, TensorFlow. And then again, the takeaway is why serverless, why infrastructure as a service. It's easy to maintain, easy to scale, easy to build. The infrastructure is transparent, which eases development. You can put dynamic workloads on it, and you only pay for what you use. So there's a little something in there for everybody, from engineers to executives, from not necessarily HR, but definitely accounting. Why streams and streaming? It's real time. You can tap into data and transform at any stage, because that's kind of how Spark and Storm is. You have your bolt here, and then it transforms the data and pushes it here, and then it might fork that as well, and then it might fork it again, and then maybe it brings it back together. And so we're kind of there, but the technology has been around. It's just the paradigm of turning it all into a pipeline. And so a good data engineer is going to build this for you and work with you to get the data that you need to do your job as well and to do it well. And that's what I try to do, is I try to get you, tell me what you need, we'll work with you, and understanding that as well. Why pipelines? Because it's the best of both worlds. You get all your serverless infrastructure or not infrastructure, and then you build your streaming processes with the serverless architecture, let's say. So remember, separate storage, separate compute with serverless pipelines. And I'm Jesse K, and I got some contact information here. I'm a data engineer. I work with the data scientists and the data. So that's my thing. I'll leave it on that. Cool. Thanks for having me, everybody.
Sure.
You have to answer questions.
Oh, I didn't know I was going to answer questions. What's your question?
So I feel like a lot of projects start with, you got some data and then you wrote a Python script and you're testing it locally. How do you go from, I wrote this code in Python to my first GCP? Like, should you put that Python code in ML engine? Should you put that in App Engine?
So you kind of need to code to the product that you're going to use. I find that Google's G Cloud console, or just the Cloud console, is just a GUI terminal emulator, and it takes all of you're already logged in, right? So it takes all the credentials that you currently have. You don't have to download an SDK. You don't have to create tokens and pass those around. You can just create all the stuff.
Data science class?
Yeah. Going in.
From the AI club, we bring a peace offering.
Oh.
We would love to.
Hi, this is
Cool. That's exciting.
We're, sorry to interrupt, we're the AI Club. We just had our meeting, so we have a bunch of extra food, so please feel free to grab anything you want.
Oh, cool.
And we can use some data, so sit down and listen.
Yeah,
Still
yeah,
there.
cool.
Yeah, we're still
Still
going.
good to go. Here, take some of these guys.
Yes,
Talking about some concepts here.
Thank you.
One for you. One for me. I have data product. So if you hear your concept, toss it to someone else. Or not.
If I heard correctly, Jesse, you're saying if you started with Python and your Python is working against your data, you basically need to rewrite it into a GCP.
Right, Google has its own APIs, and you can just pull up all the REST endpoints. So if that works with all of Google's REST endpoints for their different technologies, then it should work. It won't be so much of it'll be mostly a lift and shift, right? Just moving it over. But I find it easiest to, so if you're creating a cloud function, you develop kind of in the cloud function itself. You kind of see what is it? Well, you know what you're interacting with, right? And you can see your code right there, and you kind of, you can write a script, but it kind of just happens. It's a natural process for the most part. And then for App Engine, you end up deploying like your own little dev environment, and then if the dev environment looks good, you just push it into production, and then whatever production changes that need to be made. So it kind of, you kind of build it with the app in mind already. Does that kind of answer your question? Okay.
I was wondering if all the LinkedIn web addresses worked to GCK and Tyler.
Let's find out.
Uh-oh.
Steve.
So the ML engines
Thank you.
only work with Python, or they combine with others?
They're fine with others.
Okay.
So, they use TensorFlow, they use Scikit, and a couple others I can't remember off the bat. And most of them are Python friendly, but a lot of them are Java friendly and stuff like that too.
So do your data scientists in your shop, do they use the cloud during development, or do they do like analysis and prototyping and then they go to the cloud to do the big work? Like I pull down like a year's worth of data, I'll process it locally and get something that, that I feel that I'm comfortable with. And then I'll go to the cloud and I'll run it against 20 years of data.
Right.
And keep that on the cloud. But I found it kind of cumbersome to try to get my personal development environment mirrored and, you use the word ephemeral, that every day I can tear it down and build it back up and keep licensing straight. And, so I haven't gotten to using the cloud yet as my personal development space. I don't know whether we'll get there or not, but that's just my experience right now.
And it depends what your pain threshold is,
Yeah.
and how much trouble is it causing you, or if if it's actually not so bad. So it's kind of both. So a lot of developers, are developing in a local environment, maybe in a sample set of data. They might make their own local database, especially if like all the permissions are locked down, in the enterprise cloud, the enterprise you're working for. Right, that could be cumbersome, and maybe it's easier to develop locally and try to, fit the regular pieces, or, retrofit your dev environment to make it fit the production environment, or even like beta or EQA environment too. And sometimes it's just really simple to, spin up your own Cloud SQL machine, put some CSVs in there, like your root on your own database and no one else has access to it. And you're right, you're just running all that in the cloud, which is pretty cheap already. And then it's just easier because you're like, okay, this works in dev. I just got to git push, and they pull it down in beta or QA or something, and they test it there on maybe a Cloud SQL instance, but it just has different credentials, right? So it can be super simple. It can be super complicated. It really depends on the environment that you're in. And so we see both. But developing in the cloud, I think, is the easiest. And Google gives you a lot of tools to do it just on the fly with a lot of ad hoc commands, and then you can build objects with your own user credentials. That's my preference, is I like building in the cloud itself as opposed to my personal environment. But I've worked with a number of very good data scientists that I highly respect, and they have their own little dev environments.
Do you know what, like if you divided your monthly cost for Google Cloud support by the number of developers or people in your shop that are working with, do you know what it comes out to be like per head per month?
I have not done that. And there's different support tiers as well,
Right.
but I haven't made any of those calculations. I'm sure.
I'm also afraid of that charge thing. You put those budgets on to make sure you don't go over.
Oh, and you can do that.
One wild query,
Here, let's pass some of these up too while we're doing this. So you can actually set billing caps and billing quotas,
Right.
and you can give permissions to someone who's not, super technical, and so they can watch all that stuff for you. And that way, and what Google will do is they'll give you an alert at about 90% or whatever threshold. Let's go. Whatever threshold you set. Let's see. Yeah. This one is. This is like a whole one. Cool. Just put this one in the center. This is the big one. So is that what you're worried about? Is getting some $40,000 Amazon bill or something?
Not that quite that much, but
Right.
I don't want a $10,000 month bill either.
Right, especially in a personal account too. You might let something run, or you forget to turn something off. I know I burned through $40 in a weekend because I didn't turn off a couple of small VMs. They only have 2 CPUs or something. I don't know, 8 gigs of RAM. And then you let it run for 4 days, 10 days. You're like, that's $40 of your $300 free trial, which is not insignificant. But I mean, you could do that on a much larger scale too. And then cleaning up your cloud. So some things to not get that surprise bill is, I know in Amazon, you need to delete your EBS instances. So even though you've destroyed your machine, you still have block storage out there. 10 gigabytes of partition that's not attached to anything, but you're still being billed for. And so you might, every time you spin up a new machine, it may attach a new EBS volume to it. So pretty soon you've got a terabyte of storage, 10 gigabytes a piece, that's not being used. And then you get a $2,000 bill for it at the end of the month. So you actually have to go and be conscious of, what you're not using. And Google really promotes that. So like with your data prop cluster, it spins up your own Hadoop cluster. You run your Spark jobs on it, your Python and your data frames and everything, or your Pandas and your data frames. And then when the job is done, when the output is generated, destroy it. And it's all gone, right? And it's so quick to stand up that I like doing it, right? Like it's easy to do, and it makes sense to do it to only use what you need to, and only pay for what you're using is really what the cloud says. Pay for what you use because, right, you turn it off or you destroy it when you're done. And they make it easy to do that, so they enable us to take advantage of that. Yeah. Questions? Yeah.
Do you find though that these cloud services like Amazon, Google, are they pretty forgiving when you mess up and have that $2,000 bill?
No.
No?
I mean, it depends. If you're a Fortune 500, they might say, oh, we'll give you some credit, but they give you so many warnings, right? That, and so many alerts, and they give you so many tools. Maybe when you first started, they might give you a credit, or they might give you a discount, or they might say, well, if you use so much, like with BigQuery, you pay for your queries, right? And like the table scan. So if you get a 10 terabyte table and you keep doing select star on it, you're grabbing all 10 terabytes for each query. And even though it'll cache some of your previous queries, as it grows and needs to scan for new data and things are changed, and you pay per query, or you could pay a flat rate of 20 grand a month. And you can do whatever you want with however many users you want. So they give you tools, to just buy, the whole cow, essentially, instead of just buying the milk. But they take care of it for you and everything, to go further with the analogy. But right, they give you a lot of tools, so they're not as forgiving as you would hope, but they're people too. They're engineers behind the scenes, and they'll work with you. Especially the first few times, and especially when they'll notice something that's out of the ordinary for your account. Say, hey, you're about 50% over what you normally use, but you're already 50% over at that point. So, but they call you hopefully before it gets too big.
So if you open up a GCP account, the first year is free, and then the first like $350 is free, and they won't charge you anything until you like confirm that you want to keep going after that point. So you can go in and explore the environment and stuff, and almost everyone has a Google email. So you can just go out and go get an account pretty easily because of that, and play around and see what you think, if you like Java or if you like Python, and building out the ML engine and publishing and creating a REST API of your models and stuff like that, how you like it or don't like it.
And then 2 years later, I get some bill. Like, where did this come from?
It'll shut off after the 365. They won't charge you
Oh,
unless
really?
you have to confirm.
Oh.
According to what I've read, and I gave them my credit card, and they won't start charging it until I acknowledge after the 365 or after the $350 worth of charges for my little stand-up account that doesn't really have much in it anyway. But
I don't know about Google, but a lot of them, they don't even charge you, they don't ask for a credit card even until you hit the limit.
so
Good
if you want to go out and experiment, they also have giant data sets like the taxi data set, like the New York taxi data set, and you can do a lot of fun things in it. And then that's not your space, but you still have that big data that you get to pull off of into your little GCP account to start trying all these different analytical techniques, like feature crosses and stuff like that.
There's a lot of online courses too, like Coursera you could take, and they give you an hour and a half lab time, for the lab. The lab usually takes like 15 or 20 minutes, and you get another hour of lab time to play in each of those spaces. And that's all free.
And I thought you were asking for like an enterprise. Sarah's absolutely correct. Google is very forgiving for your personal accounts. Yes, you take the risk of like you have to give them your credit card information before you're even allowed to use the service, unlike some where it's just free. And they give you a credit, but you explicitly opt into things and they will stop. As soon as you hit that zero limit and you have no more credit, everything stops. And then they say, hey, would you like to continue your processes? Would you like to add some money to the account? For your personal exploration, I'm going to say it's absolutely risk-free. I've done it myself, and I still have, God, it was like 3 months ago, I still have $170 in credit, and I'm not worried about, excuse me, getting some huge bill. Excuse me, we shouldn't even talk at the same time. But yeah, so for your personal exploration, it's risk-free. It's sketchy to give a credit card for a free trial. You don't have to worry about it. So yeah. I didn't realize that was the question you were asking, so everything Sarah said is absolutely correct. And I've done it myself, and I haven't had an issue with it. Cool. Yeah.
Thank you.
Yeah. More questions?
In terms of, where do you see the cost in terms of the amount of queries that you do going forward from Amazon? You see it going down even further? Do you see it?
They're trying to stay competitive. You want to use, there's so many variables. Over time, I think the cost will go down, but as storage will get cheaper, memory may get cheaper, maybe it won't. Technology gets, traditionally gets cheaper over time, but when you start developing more processes on that technology and relying on it more, you end up using more of it. So while the technology itself is cheaper, because you're using so much more, your bill ends up going up. So is it cheaper? Yes and no, right? Just depending on how much you use. But there's still lots of cloud vendors out there. And really, we're not looking at necessarily how much does this cost as what problem will this solve for me. And that's where the real value comes in. Maybe it's a little bit more than a competitor, than AWS or AWS versus GCP or Azure or something. But if they have, you can take advantage of Google's machine learning APIs, and if that solves your problem, and solves it easily and quickly, maybe there's more value in paying a little bit more for it. Or maybe it's even cheaper. That would be cool too. But I think that's where the focus, like trying to turn the question on its head a little bit. Yes, to answer it directly, the cost will go down, but you'll end up using more of it, so it'll still cost. It'll be, Thank you. Who brought the pizza?
The AI club?
Hey, nice. Thanks, guys. That was good.
Just give us some data in return. We're good.
We should coordinate when meetings are so we don't overlap.
We were actually just hanging out like long after hours, and he was smart enough to sort of signed up for notifications about this one. Realized we could just find you. One thing to note, we couldn't find the room number though. On the,
Really?
I don't know what the.
Yeah, it gave the building address, and like, yeah, we're here. Where's
Oh,
the
well,
meeting?
The sign's out in front on the door. I didn't realize it wasn't out on the website anymore. It used to be on there.
Oh, I didn't check the website, I would check the Meetup.
Yeah, it's on the Meetup page,
Oh.
or it was on the Meetup page, the 2 meetups ago. So, I will verify, and if not, I'll fold it and make it huge.
Okay, good.
So, sorry about that.
Oh, no worries.
Might also just in the mobile app version that just showed the address, like basically in the same field as the address was the only reference we had, so that address line would be maybe where the room would be.
I also need to put up signs around BSU, saying data science meetup. That's something I need to work on.
And the AI club, we have about 100 people in our Slack.
Oh, wow.
So we can send, reminders saying, hey, there's a data science meetup today.
That would be super cool. We should
Yeah,
coordinate.
okay,
I
your
think I
contact
have your email, or I can give you my
Yeah,
stuff.
yeah.
Yeah, I was going to ask you guys what works for you guys in your group. And Slack works pretty well.
Yeah, we're all in Slack. Yeah. And we just need to populate it with some buffs, and, otherwise we're not really the AI club.
That's good.
Well, thank you for dropping by and bringing us pizza and everything. I know usually the rule is with the Boise Data Science Meetup that we have meetings once a quarter, and usually we agree when the next meeting will be at the meeting. So I don't know anyone's feelings about February or March or preferences. Usually we do a Tuesday evening. But is everyone okay with doing a meeting in mid to late February, early March? I got a few head nods, so I'm guessing that's probably as good as it's gonna get, so. And does anyone want to give a talk? Or I will start reaching out to you on the internet, which everyone loves when I do that. So does anyone wanna talk about anything or talk about neural nets? Is always a favorite thing, or anyone have any theses or research that they would like to talk about?
I mean, I was only partly joking about you guys giving us data.
I can give you data. You want?
Well, I mean, one of the discussions that comes up in AI is, how do we get data that people aren't already exploiting, people aren't already using it with more resources than a small AI club, but you guys being, in that area, maybe you have some ideas of where we can find stuff, I don't know.
Have you looked on Kaggle at all?
On what?
Kaggle, Kaggle.
I haven't.
There's a lot of competitions on there. There's also a lot of competitions with predicting stock prices. And we actually started a little group, it's not very active, to do that with the Boise Data Science Meetup, using neural nets and stuff like that, recursive neural nets to predict the next day's closing. And we were having a little bit of fun with that. And oh really? Because Jason and I were trying to work through that. And then there's all these public data sets in the GCP that are really easy to query against. You just have to make an account, and then you get your data lab up and running. And it might sound like that might be something we should maybe walk through next time, is getting a data lab instance up and running and writing some Python code and maybe querying some public data. And it's really easy to pull up, like, they have a New York taxi data that's like really cool that you can do, that's real time and all of that, and it's big data.
Is this on Kaggle?
No, it's in the GCP. They have a bunch of public databases. If you just Google search.
Baker also has a GitHub repository, like all of the code there is a part of Baker.
Is there any particular questions you're interested in? Is there any particular type of data you're looking for?
I mean, like
particularly you want to-
biological.
There's all
Or,
kinds of sports, there's.
yeah, anything you can think of. There's probably a data set for
Yeah.
that.
Yeah, there's got to be like records of who's won every MLB or
Oh,
NBA.
yeah, you go back 20 years.
Somewhere.
Play-by-play data.
There's like baby birth information. There's like happiness by country and all those different ratings that you can do.
Found a database of popular baby names historically, like for every year, the most popular baby.
They've used spectroscopy on wine and correlating that to different tastes. So spectroscopy is extremely highly dimensional, and then all the different types of wine is also highly dimensional, and so then you have this many variable by many, different types of wine.
See, that's kind of an example, kind of thing I'm thinking of, because to me, one of the big challenges is actually just finding creative new ways of getting information that has some sort of application. Like we've got in science all sorts of instruments and everything that we can use to gather data, but it's finding something that can actually be applied with, machine learning algorithms and whatnot. And that wasn't, I know you guys use TensorFlow and all that kind of stuff, so from some of our discussions in the AI Club, we were kind of struggling to think of anything of where to go, but that might be a good collab of trying to think of new ways for that to work.
Well, I mean, like, what type of methods are you interested in? Are you, like, everyone's always talking about deep learning and neural nets. Those are kind of like the buzzwords. But there are also other methods out there, like isolated forest that's based off of random forest. That's one of the newest, like, fraud detection methodologies that are out. But I'm sure most people haven't heard of it yet because it's new. And so there's a lot of stuff out like that that we could even talk about even. So, and as exciting as it would be for me to give another talk, I can talk through GCP and importing data if someone gave me some input on what data they want, but I need some participation from you guys about maybe presenting on a method and just talking for 20 minutes, say about isolated forest or about recursive neural nets and how to use them and how, it applies to this problem and just walk through it to a problem. It doesn't have to be that big, but need some participation from you guys. Otherwise, I'm stuck cornering people like Jesse at my work and making them present.
You tricked me.
So I need some volunteers. Not that I'm staring at anyone.
Volunteers for like ideas of what sounds interesting or
Or
like
I need
presenting?
some presenting on a topic, because even if I were to present on it, I'd have to sit down and like research a new method, then work through applying it to the method, then getting some results, and then making the slide deck to go with that. And if I'm going to present on GCP and building out data lab and how you query against the public